Now today's job, I want to fill in some of the information down here. This is a extended backbone tree, so it's a phylogenomics backbone, which I've done a bunch of grafting on. And I've done gap filling, tried to get additional phylogenies, but there's a particular problem. These are all noctuids at the bottom here, and it's quite very difficult to get to integrate phylogenies. There's not really much available. Now, I've been wondering what to do about this. I will try my best to get some more published results in there, but otherwise, I thought of another option. I thought of this paper here, Smith and Brown, and what they do is they make supermatrices for subsets, with a fixed backbone, and make supermatrices using the old clustering method, locus clustering, and picking out the species rich markers and making a supermatrix. So I thought I could try this. So to do this, I need data from NCBI, because in this case bold is just for DNA barcodes, so we need a bunch of other markers, so we need NCBI. In recent years I've shifted to bold, but I previously used NCBI all the time. So here's so I'll try with an old database. This one's from 2019. This is all hexapods and the process database. So we have the FASTA database, 2 gigabytes, and a key file. Key file looks like this. These codes, these can be ignored. These are some old legacy thing, but we have the species IDs in the second column, and this is built from the taxonomic hierarchy, and it has, so for each species ID used on NCBI, I'm going to pull out the noctuids from this grep for family Noctuidae from the taxonomic key file for all hexapods, and just put all those into a single line. Now I need a bit of, this is easiest with a bit of Perl code. I could write a little script, but when you have a small number of lines, one option is just you can, in your bash code, you can just have use echo and pipe that into a temp script so you can see exactly what's been doing. Just develop it here. So opening the key file, I'm pulling out the second column, which has the species IDs, and so this taxonomic file is for all ranks. So we just want species, so limit to whether the rank column just has species, and then pull out the species ID, store this, and print it to a file. Then we can have a look at this file. So you can see a list of species IDs, in this case limited to binomials. Use the read array, put this into a bash variable, loop through all these, and grep this is the FASTA file of all invertebrates, or all hexapods, and you can see the species IDs, but also within that session. So I'm grepping for the species ID and underscore, and it will get all, because there'll be multiple sequences per species. Now, how I originally used NCBI quite a lot. So to make this was originally published in with a collaboration with Anna Papadopoulou, and in this case it was plants, but you can use this for the invertebrate division also. There's a small number of divisions for NCBI, and you can pull out the flat files for those and make this file. The code is was from a while ago now, but it's still on SourceForge. Go to Bagpipe, and you can see the code here. Pipe, and so you obtain the release you need, plant release or the invertebrate release. You do this with wget, and also you need a taxonomic NCBI taxonomic database from the file transfer from the FTP site, and to create just a couple of scripts to actually make these processed faster databases, parse NCBI text database and this one here. So just 2 scripts, and then you can make this. You can make these 2 files yourself. So this is what I've parsed and pulled out all the noctuids from this, just with using grep. Use the -A1, so you match the faster ID line plus the following line which has a sequence on. This is some odd thing I've never figured out. For some reason you get a couple of hyphens on an extra line. I don't know what that's about, but trim those off. And we should now have a noctuid, a NCBI file, which we have here. So 37 megabytes, and you can see these are all ordered, so multiple sequences per species, and these because these are from NCBI, these could be any, quite a variety of markers, not just CO1, not just barcodes. So we'll be doing a multi-gene analysis. So the next steps will be locus clustering, as they've done here, and I've done this myself in previous projects. So this is all implemented, and we can build a supermatrix for taxonomic subsets. Now this is so most of these are so this is a unresolved, so there's no backbone information for these, but there's only co-ones now, because there's this, these are from even a single family, and you can't really expect co-1 to resolve. So you can see here subfamily Hedoninae, this is a noctuid subfamily, and normally I would just use co1, and you can't really expect good resolution for co1 at this kind of range. So I'll add a multi-gene matrix for this. There might be some additional soft constraints I can apply, although for whatever reason, can't graft onto here, but there's probably a few soft constraints also, but maybe like they've done here, a super matrix should give some good resolution. Now, not sure exactly how this is going to be done, so I'll build one super matrix which will, I think this is from a different family, so this single super matrix for these Noctuidae, which should cover these 2, and could apply for this tribe here. So I guess that would be, I would build that independently. And now if you try and build a super matrix, like aligning one marker for several families, it quickly becomes a quite difficult thing. But if you can limit it to, because we're constrained between these, we don't really need to align it over the whole thing, we just need to align. So we can have separate partitions. So I'll probably build one supermatrix for this family and one for this tribe, and the rest of it's fine, it's pretty good. We can rely on co1 for resolving within these tiny things here. So that's what's next, but for today we have the NCBI data required to do this, so job done.